Good morning, students. Today we start with a new chapter, continuity and differentiability. Actually, both the things are different, continuity and differentiability. So the first thing we see the continuity of the function. But before we go for a continuity of the function, first we see that limit of a function. This we have seen in the 11th standard. What is the limit of the function? So you know that if a left-hand limit is limit of a x tends to a minus fx, and the right-hand limit of the function, I'm not going to that fixed definition, are exists and are equal and is equal to L, then we say that the limit of the function exists, and that limit we say as the limit of x tends to a, fx is L. This is called the limit of the function. If a left-hand limit of the function and the right-hand limit of the function exists and are equal, and that is equal to supposed to be L, then we say that the limit of the function fx is L when x tends to e. But here, definitely one thing is that x is not equal to e. So you can also define like this, if f is a real function defined on a real numbers, and if a is any element not containing that domain of the function, and if limit of fx is L when x tends to a, you can say that limit of the function is L. Some rules you have seen like this, the limit of the constant function is constant if k belongs to R. Second thing, limit of any function, identity function x is equal to x. Even you can say limit of x tends to a, x raised to n is what? X is a, sorry. X is a. X tends to a is what? A raised to n. Some basic rules you have seen in the 11th standard. X tends to a, x raised to n minus a raised to n upon x minus a is n to a raised to n minus a. Like some trigonometric points you've seen there, like a limit of x tends to 0, sin x is what? So say sin 0, and that is equal to 0. But limit of x tends to 0, cos x is what? Cos 0, and that is equal to 0. So we derive another two more rules from that. We limit of x tends to 0, sin x upon x is 1. Like this, limit of x tends to 0, tan x upon x will be also 1. Okay? There is few more things like that. The limit of x tends to 0, a raised to x minus 1 upon x is nothing but log of a to the base e. These results are very, very important. Similarly, limit of x tends to 0, e raised to x minus 1 upon x is also log e to the base e, but that is equal to 1. Few more things are there like that. For infinity function, limit of n tends to infinity, 1 upon n is 0. Just you think, this is a new point for you people. Just you think, n tends to infinity means we just take the value of n as 10, 100, 1000, 10,000, 1 lakh up to so on. But when you take the reciprocal of them, means 1 upon n will be what? So say 1 upon 10, 1 upon 100, 1 upon 1000, 1 upon 10,000. Just you think this value of 1 by 10 is 0.1, then 0.01, 0.0001, 0.401 means that value goes closer and closer to what? 0. So as n tends to infinity, 1 upon n is 0. So these are the working rules we use for finding the limit of the function. We use for the limit of the function. Here few things are there, basically. If I take one example, limit of x tends to 2, 2x plus 3. That is okay, you get it, the answer will be what? 7. But here x is not equal to 2. Here x is not equal to 2. So when we plot the graph of, as the x tends to 2, what is the value of 2x plus 3? So if I plot the graph of that function, आप जरा सोचो, this 2, and when you keep a 2 it will be 7, but 2 we are not taking, so 7 will be not come. But when you take x0, then it will be what? 3. Suppose this approximately value. If I take x1, then it will be 5. So if I plot the graph of this function, it will be a straight line. अब सोचो, if I take a minus 1, the minus 2 plus 3 is a 1. If I take a 3 plus 3, the 3 2s are 6 plus 3 is 9. So this side only you get it. So the value will be going up. Here, when you take a negative value, the value will be going down. But see here, if you see the nature of the curve, it breaks at a point x is equal to 2. So that's why this function is not a continuous function. That's why this function is not a continuous function. Understood? So this is a story of a limit of the function, which is in which we find the limit of the function, which will be not continuous. The graph will be not straight line or straight, unbreakable. Okay. Now we have to see the function in which you can plot the graph unbreakable, or you can say that without break we can make the graph. So see, now the next thing we go on that. See, so that we call as a continuous function. Now this is about the limit of the function. Now we move to the another one, continuity. So say that same thing. Suppose f is a function defined on a real number. Means it's a domain and the codomain are the real number. If a C belongs to domain of the f, C belongs to domain of f. See, in the limit of the function, that value does not belongs to domain of f. And if limit of x tends to C, fx is equal to fc. If a limit of x tends to C, fx is equal to fc, then we say that f is continuous at x is equal to C. I repeat, let f be the function defined on a real number and C belongs to domain of f. If a limit of x tends to 0, fx is fc, then we say that the function is continuous at x is equal to C. So here you have 2 points for the limit continuous function. First thing is this, again I am repeating, limit of x tends to C, fx is what? Fc. Now the question is when the limit of this function exists. So say if left hand limit and the right hand limit exists. So another definition for the continuity of the function at a point is x tends to C minus. This is what left hand limit of the function is equal to limit of x tends to C plus. This is called the right hand limit of the function exists and equal to f of C. Then we say that the function is continuous at x is equal to C. Means here both the things are possible. If both the things are possible, you can say that. Means both the meaning is the same, sorry. But if it is, thing is possible, you can say the function is continuous at x is equal to c. Now, if any one thing is not similar, if a left hand limit exists and right hand limit are exists but not similar, so that function is discontinuous. It's not continuous. Maybe these two are equal but they are not equal to fc. Okay, ये दोनों similar है but ये fc जैसा नहीं है. Then also the function is not continuous at that point. If limit of x tends to fx is not equal to fc, then also the function is not continuous at that point. So if this all the thing is possible, then only we say that a function is continuous at x is equal to c. Otherwise, the function is not continuous. It means the discontinuous at that point. Is that clear? So this is a continuity at one point at x is equal to c. Now the thing another is also possible. If the function is defined on a real number, if the function f is defined on a real number, here I took a point, but if the function is continuous for every element of the domain of the function, not only the c, but it's continuous for every point of the domain of that f, we can say that a function is continuous function. Two things are there: continuous function at a point and continuous function. Means it's continuous for domain of every point. See, a few things are also important here. Here you can say constant functions are always continuous. I just give you one example. Limit of x tends to a level, k is equal to k. K belongs to 1. Constant function is always continuous. Just you think one example. They say limit of x tends to 2, fx is I'm taking as a 3 is equal to 3. You know that. See, if I plot the graph, your answer will be what? 3. आप कोई भी समझो यहाँ पे 3 है. This is 3. If you take x is 0, it is 3. If you take x is 1, it is 3. X is 2, it is 3. X is 3, it is 3. X is minus 1, it is 3. So that means you take a real number between 0 and 1, also it is 3. You take a number between 1 to 2, it is 3. So when you plot this graph, unbreakable, without breaking, it is a straight line or a line parallel to x-axis. You can see the nature of the graph. This is called the continuous function only. अगर आप उसका ग्राफ बनाते हैं, वो कहीं पे भी आपका ग्राफ ब्रेक नहीं होता है. It's not necessary कि ये straight line ही आना चाहिए. Your curve should be like this maybe. No problem. But it's going in infinite way. It is what a continuous function. आपका ग्राफ कहीं पे भी ब्रेक नहीं होता, then that function we call as a continuous function. Similarly, second point is polynomial functions are always continuous. Polynomial function means like a linear. In this example, it is a constant function, but supposed to be 3x if I take. So your answer will be 3 to the 6. Okay, linear functions are always continuous. Quadratic like that, you get a different graph there. Okay. The third thing, rational function. Polynomial means px, I say. Rational function means px, a function in the form of px upon qx. Okay. So a function which is given in a rational form, polynomials, that rational functions are also continuous. So constant function, rational function, polynomial functions are continuous. Even you can see the graph of a sin x. It is always continuous between 0 to 1, minus 1 to 1, sorry. It is between always minus 1 to 1. Sin x, cos x. So again you can say the trigonometric functions are also continuous in their domain only. I repeat, in their domain only, this trigonometric functions are also continuous. Means you can say limit of x tends to a, sin x is what? Sin a. Like this you can express for cos x is what? Cos a. Limit of x tends to a, tan x is what? Tan a. Limit of x tends to a, cot x is what? Cot a. But that will be in a proper domain. Is that clear? अब tan के लिए हम कोई ऐसा डोमेन नहीं लेंगे जिसमें tan will be undefined, जिसका ग्राफ ना मिले. Is that okay? Another thing related to this given that is supposed to be f and g are two different functions are given. If f and g are two different functions are given and are continuous at x is equal to c, they are continuous at respective point. We can say number one, f plus g is also continuous at x is equal to c. The addition of two continuous functions is also continuous at that point. Difference f minus g is also continuous at that point. Similarly, f into g is also continuous at that point. Fourth point, f upon g, but this g should not be a zero, is also continuous at that point. Like this, fifth, little bit different. C into f is also continuous, or C or k into f, where k belongs to R, is also continuous at x is equal to c. Similarly, 6, k upon g, g is not equal to 0, is also a continuous at x is equal to c. And if f is a continuous, some little bit different point, modulus of f is also continuous at x is equal to c. See, here we have only the main definition is this two. And we are accepting this results. If the function is continuous, what will be happens? See, here not sums are very different way given here. That we see. But another point is we see composite function. You know, when the GOF exists, when the GOF is exists, so say if a range of f is a subset of domain of a G, means suppose f of a to b and g of b to c given any function, this will be I am taking similar, or maybe this element range of the function are subset of domain of G. मैं similarly ले रहा हूँ, so there will be no confusion. Now, if f is a continuous or a domain of this element, for every element of the domain of the f is a continuous. This G, अब जो भी f a आया यहाँ पे मिलेगा, f a means range of the function that will be present in E. So G is a continuous at what? f a. So GOF should be continuous at what? Every point of the domain A of the function, because GOF function becomes what? A to C. So GOF is always continuous at every point of the domain of the GOF. So this is a story of the continuous function. Now we have to see some examples of the continuity of the function. It's very simple. Now see the exercise number 5.1, the first sum based on a continuity of the function. Prove that the function fx is equal to 5x minus 3 is a continuous at x is equal to 0 as well as at x is equal to minus 3 and x is equal to 5. Now when you say the function is continuous at x equal to c, so say limit of x tends to c, fx is equal to fc. So we just find out the value. First of all, we go for x equal to c. So limit of x tends to 0, fx is what? Limit of x tends to 0, fx is what? 5x minus 3. If I keep the value, so 0 minus 3 is minus 3. What is the F0? So keep the value. So 5 into 0 minus 3 is minus 3. So therefore, limit of x tends to 0, fx, or you can say 5x minus 3 is equal to minus 3. So therefore, you can say that f is continuous at x is equal to 0. Similar way, we go for a second point. At x is equal to minus 3. So limit of x tends to minus 3. fx will be what? Limit of x tends to minus 3. fx is 5x minus 3. So it is a 5 into minus 3 minus 3. So it is what? Minus 18. You can also see f of minus 3 is what? So say 5 into minus 3 into minus 3. That is also minus 3. So therefore, limit of x tends to minus 3. fx means 5x minus 3 is minus 3. So therefore, f is continuous at x is equal to minus 3. See, even in place of this, we can also write limit of x tends to 0, fx is what? Fx. Here we can write limit of x tends to minus 3, fx is what? F of minus 3. Alright, for third like that. Third case, at x is equal to 5. See, the same thing, limit of x tends to 5, fx means limit of x tends to 5, 5x minus 3. So 5 5s are 25 minus 3 is 30. F5 will be also the same, 5 into 5 minus 3 is 30. So therefore, limit of x tends to 5, limit of x tends to 5, fx is equal to f5. Or you can say limit of x tends to 5, 5x minus 3 is equal to 1. So therefore, f is continuous at x is equal to 1. Is that clear? Even we can see the graph of this function. Fx is what? 5x minus 3. If I plot, see this, all the things are clear. I just draw the graph. We just make a table. See. Just you think x and fx. Here I am taking minus 3, minus 2, minus 1, 0, 1, 2, 3, 5. Are valued up there. You will get it what? If you take a minus 3, then that will be what? Minus 3, then minus 15, 18, minus 10, minus 13. Okay, so your line will be like this. Okay, I'm randomly just plotting, not accurate. ऐसा ही कोई एक straight line है. Is that clear? 0 then minus 3. So it should be like this. 0 then minus 3 means it will be crossing to like this. Okay, so just take care of this. When your line is straight, the function is what? Continuous. X is 0, then plus minus 3 means this side it will be. Sorry. Understand? Pause.